Hello students. So students, we have today we will start with the new chapter, that is chapter number 5, model 5, designing IP addressings in the network and selecting routing protocols, right? So basically this particular model 5 is divided into two parts, right? The first one is how to plan the IP addressing in the particular network, right? And the second half is for your routing protocols, right? So we will see in all the two halves, but before that we will see what we have covered in our till last sessions, right? So if you see in recap part, right, so we have discussed with respect to our module 4 for designing remote connectivity, right? So in that we have demonstrated, we have illustrated there are different WAN technologies, right? So there are traditional WAN technologies also there, and there are some different other than traditional technologies also there, right? So all these enterprise age WAN technologies we are going to design, right, in the WAN design part. And again how this particular WAN you are going to design with the help of these WAN technologies, right? And what are the different considerations while designing this particular WAN, right? That also we have discussed. Then WAN and MAN architecture with respect to enterprise age also we have seen. Then how we are going to select a different age components for the enterprise WAN design part, right? And how you are going to use all these components for designing this particular WAN, right? That also we have seen. And at last we are covered the enterprise branch and the daily worker design also, right? So in that we have seen how the sizes of the network of your branch, right? For example, the small branch offices are there, medium size offices are there, then the large offices, branch offices are there, right? Then how the network topology will be there with respect to all these kind of the branch offices. And for the teleworker design also we have discussed, right? So all these are nothing but with respect to our remote connectivity, right? So this particular model we have covered till our last session, right? So today we will discuss with our 5.1, that is designing an IP addressing plan, right? So here in this particular first point of this particular module, right, we have a different kind of the things with respect to your IP addressing, right? For example, you must know what you mean by the private IP addresses, what you mean by the public IP addresses, right? What are the range are there with respect to the private IPs, and what are the what do you mean by the public IP addresses, right? Then how you are going to define this with respect to the size of the network, right? Then how that particular individual locations of this particular network sizes will be there, right? And all these things we will see one by one, right? So in today's session this particular 5.1 will be divided into number of lectures, right? So I will require 2 to 3 lectures to cover this particular 5.1, right? So what I am going to do is I will just today we will see this particular what I mean by the private versus public address selection criteria, right? That we will see today. And after that I will demonstrate give you the demonstration with respect to your NAT, right? That is network address translation, which is also one of the our experiment, right? That is your experiment number 3, that is natting, right? So that I will show you how it will the natting can be configured in a Cisco packet tracer, right? Because because that particular concept will be very much important with respect to whenever I am talking about this particular private IP address and addresses and the public IP addresses, right? So that we will see over there, right? So all you know already this particular IP addresses space, right? So it will be divided into the two spaces, mainly the public spaces and the private spaces, right? So private spaces, or you can call it as private IP addresses, right? So which will be a reserved IP addresses, right? So all these private addresses, reserved IP addresses, we can use only the internally, right, within a company's network or any kind of the organizational network, right, and not on the internet. We are not using this particular private IP addresses on the internet, right. So these are that are nothing but your public addresses which you are going to use on the internet, right. So these private addresses which you must be map to this your organizational external registered addresses, right. So whenever you wanted to send anything to your internet, right, and this particular public IP addresses which will be provided for this particular external communication, right. So if you see in this particular diagram also, right, so which will be giving you the uses of private and public IP addresses in this particular network, right. So here on this particular boundary point we are going to use we are doing some translation over here, right. So public to private or private to public and all that things, right. So you must know what are the range or what are the different addresses which will be a part of your private internets or private IP addresses, right. So for example, the 10 series IP or 172.16 series IP, or this whatever we are using in our college also, right, so 192.168 series IP, right. So these are the nothing but your private IP addresses which we are going to use, right. So, and remaining IP addresses which are other than these, you can be used as a public IP addresses, right. So these we have a very few public IP addresses that is currently available. So whatever the ISPs, right, which will be assigning you only a subset of these particular class C addresses to all the customers, right. So therefore the most of the cases the number of public IP addresses, right, so which will be assigning to any kind of the organization, right, which will be inadequate for addressing your entire that particular organization network, right. And the solution for this particular problem is, so you can use the private IP addresses within your network, and you can just translate that particular private IP addresses to your public IP addresses, right, and whenever the internet connectivity you will require, right. And so these particular translation process we can call it as a NAT, right. So you must know, the network designer must know some of the questions with respect to that, right. For example, how many IP addresses, public, private, or both IP addresses will be required by that particular organization or not, right. So how that particular end users, how they are connecting or how they are going to access that particular public network, right. All this kind of the thing the network designer must know before designing or before planning the IP addresses scheme over that particular organization, right. So in this if you see the network address translation, right, so whenever we are going to use the private addresses, right, in your network, right, and you need to use the some of the internet kind of the thing, right, then you need to translate this particular private IP into the public IP, right, and for the rest of the world you will just demonstrate the public IP address instead of this particular private IP addresses, right. So that's the concept which we can call it as network address translation or NAT, right. And if you are doing some port address translation, then you can be called it as an PAT, that is a port address translation over it, right. So we will see first of all how this particular NATing and this particular PAT can be done with the help of our one of the experiment, that is experiment number 3, that is your how to configure this particular NAT on a Cisco packet trace, right. So you will come to know that how this particular NAT concept will be worked, right, how what is the need of this particular concept, right, how to configure this particular NAT on a network infrastructure, right, how to assign IP addresses, how to giving the default route to your internet networking devices and all that things, right. So that's why I will just demonstrate you first of all the NAT part, right, then we will move further our next concepts, okay. So just move to the configuration of your NAT, okay, then we will come back to this particular topic, right. Okay, hello students, today we will start with our experiment number 3 for our network design lab, right. So if you go on a Moodle course page of NDL lab, right, so you will find out there on tab number 2 that is experiment number 3, to design and configure a simulation for NAT server, right? So NAT is nothing but your network address translation, right? So we will first understand what will be the required as a prerequisite for this particular NAT server, right? So if you see the same things which we are covered in our last practice as well, right? For example, the DHCP server configuration, right? So we will require here the knowledge of basic concepts of networking again, right? Then the exposure of the Cisco packet tracer tool again, right? So here we will require to know about this particular network address translation concept, right? So what do you mean by this particular NAT, right? That we will need to see, right? Then the static netting means what, right? That also we need to check, right? Then the IP address classes we must know, right? So class A, class B, class C, class D, E, and what the different their ranges over there, right? So that also we need to see, right? Then here we will add in from this experiment, because if you see in the first two we have not yet used that particular Cisco packet tracer CLI, right? That is command line interface we are not used yet, right? But from this experiment we are going to try to use all these things of in the CLI itself, right? So from the CLI, how to configure the router, and there are different servers, right, which will be required. So how to configure that with the help of the command line interface, right? So that we will be see, right? Then again networking devices, you must know the functionality of internet networking devices, switches, routers, you must know, right? The OS layers and all this part also you must know, right? So whatever the basic prerequisite for your enterprise network design subject, right? All the things it will be required for this particular experiment, right? If you concern, right? Then the problem statement, if you see, right? So students are expected to configure router for the static netting, right? So we need to configure here the router by using some command line interface, right? And for our static netting, right? So network for static network address translation, we need to configure router, right? In that particular Cisco packet tracer itself, right? So we must identify the benefits of the netting by creating all the static netting simulation, right? So we must know what are the different advantages of doing this particular netting part on in this particular network infrastructure, right? Then also you must understand or how to use different IP address classes to different internet networking components, right? And how to understand this inside and outside the network, right? How this particular private IP can be translated into the public IP, right? So that we will, that is nothing but the netting, right? And how the respective changes will be happen in that particular PDU header, right? So that also we will see, right? So here what we are going to do is we are just hiding this particular IP address of our server, right? And we are just demonstrating the public IP of this particular server to rest of the world, right? So that is nothing but your the netting part, right? So network address translation we are going to do by keeping hiding our private IP of our own system, our own server, right? And just demonstrating them with the public IP of this particular router or internet networking devices which we wanted to show to all the public domain, right? So that's we need to configure in this particular experiment, right? So if you see in this topology, logical topology also, right? So one second, I just zoom it. Okay, so if you see in this particular logical topology, right? So I have configured a simple very small network topology here by adding some two routers over here, one switch, two PCs, and one server is there, right? So if you see I have configured this PC0 and PC1 with the IP 1.0 and 1.101, right? So router which having for this particular interface FA0/0, I am having an interface with 192.168 series, right? But for this particular serial communication, I am having something different range of the my IP address, that is 200.10.0.1 range, right? And the same range I will be using at the another end of this particular router, which will be connected to this. If you see in this particular two routers, I am using here the serial communication, right? with clock. And if you see here, you can see the symbol of clock, right? So that is nothing but the serial communication with clock, right? And here also at the end of this, I'm using this particular 200 series IP address, right? And again, from this particular router to server, I am using this particular crossover cable, right? So that's why here, if you see, the dot dot dash dash cable is there, right? So it will be nothing but the crossover cable, right? And for this particular interface, I am using again the 10 series IP, right? And the server IP, I have set it as a 10.0.0.254, right? So I am doing here the netting on the configuration of this particular server, this particular router's configuration, right? Of netting part, right? And I am just showing you before netting what will be happen, and after netting what will be happen in the simulation part, right? So first of all, we will see the theoretical part of for this particular experiment is concerned about netting, right? Then we will move towards the packet tracer part. Okay. So if you see in this particular netting experiment, right? So you must know what do you mean by the static net, right? So it is nothing but the network address translation, right? So one-to-one mapping in between these private IP addresses and the public IP addresses will be take place, right, in static netting, right? So and it will be very much useful when network devices which will be inside a private network needs to be accessible from the internet, right? For example, if you see from the outside the network, you wanted to access our college private network, right? Then at that time this particular netting can be useful part, and it can be done over there, right? So I think you must you understood that why this particular netting can be done, right? So whenever you will require to access the private inside kind of the network from the outside public domain, right? So at that time this particular netting can be done, or netting can be helpful, right? So so there is another concept also, the dynamic netting will be there. So it will be a mapping of private to public address from the group of public IP addresses called as netting pool, right? Like we have discussed in our last practical also in the for while configuration of DHCP pool, right? So here that there also we have defined, or we have configured one DHCP pool, and we are given one range of that particular IP addresses of that DHCP, right? And from the range of the IP addresses, right, so we have given randomly or automatically IP address to our client systems, right, from that particular DHCP pool itself, right? So according so similar to that, we have here the dynamic netting, right? So we have a netting pool over here, right? So it will be map the private IPs to the public IPs from that particular group of public IP addresses which we are available on this particular netting pool, right? So it will also give the one-to-one mapping for private to public IP addresses, right? So in this case this particular dynamic netting can be used, right? Then we are also having the port address translation, that is nothing but the PAT we can call it as, right? So network address translation having two types, the static NAT and the dynamic NAT, and also we have an PAT, that is port address translation, right? So it will be another type of your dynamic NAT, right? So so which can map multiple private IP address to a single public IP addresses, right? So using a technology called as an PAT, right? So if multiple IP addresses one can have, right? So we can be we can allocate to only one public IP addresses to show to the public domain, right? So it's called as an port address translation, right? So we can call it as an PAT, right? So some terminology for static net, also net outside interface, right? So we need to define a net outside interface in our configuration part, right? So which we can be called it as a public network, right? Then the local addresses, which will be again a private network, we can call it as, and the global address is nothing but again a public portion of the network, right? Then legitimate IP address is nothing but the we can call it as service providers or the NIC which will be given the IP address directly, right? Then the inside local addresses is also one of the part, outside addresses, inside global, outside global, that we will be see in this configuration part. Then you will be understand easily what is mean by that, right? So if you see here, again the same topology which I have explained in previously, right? So all this part you need to drag and drop from this end devices and the switches and routers and servers, right? So at that so you need to give static IP address to the end user species, right? So for this, now if you understand, we are given the dynamic IP addresses from the DHCP server, right? And in our last experiment, that is DHCP configuration, right? But here you need to provide to these particular systems a static IP address, right? So how to do that? Just click on this particular we can call it as an PCs, right? Double click on this and go to your this particular desktop, right? And you just need to use this particular static part, right? And here you need to provide the IP address to that particular PC, right? And if you see here, I am using the default gateway as nothing but my router's IP address, right? So if you see here in this particular router, right, so I need to configure this particular fast Ethernet port as this particular IP address, right? So that we will see how to assign that, right? So same way I have given here the same router's IP address as the gateway, and for PC1 I am again using some static IP address, something different. Here I am using 1.100, here I am using 1.101, right? So two PCs I have configured, right? Then I need to check for this particular R0, that is nothing but my router first of this particular topology, if you consider, right? And just you need to go with the CLI command, that is nothing but the command line interface, right? So now I am going to give you the explanation of all these commands, right? So what it is exactly, right? So first of all, you need to in R0 you need to fire a command en, right? So I think it is not a part of this particular screenshot, right? So en is nothing but the enable, right? So you need to first of all enable that particular router, right? And after enabling that, you need to use the terminal of that particular router in order to configure, right? So in order to configure the interface, right? So here I am using conf space t for the configuration terminal of this particular router 1, right? That is router 0 here, right? So configuration terminal of router 0, if you put it, right, so it will be changed to your router into bracket config tab, right? That means you are under the configuration of this particular router, right? Then you need to select that which interface you need to first of all configure, right? For example, if you see in this particular diagram, right, so FA0/3 interface you need to configure, right? From this particular router 2 to this particular interface you need to configure, right? So that's why I'm choosing here the FA0/3, for example, which will be going from this particular router to this particular switch, right? So here I am putting here interface FA0/0, right? Sorry, in this also, yes, in this also it is an FA0/0, right? FA0/3 is nothing but the interface of this particular switch for this particular cable, right? And for this particular router, this FA0/0 you need to configure first, right? So FA0/0, then I need to put it here INT means for interface, FA, that is fast Ethernet 0/3 0/0 port, right? Then you need to provide IP address to that particular interface, right? So I need to give IP address to this particular FA0/0. So I am giving here IP space address space, this is the IP address of that particular port and the net mask for that particular IP address, right? And then I am putting here the no space shut, so therefore no shutdown, so that the cable will be that interface will be enabled, right? So after that, if you see after doing that, if you see this particular you can call as an cable will be in a green color, right? So that so therefore the whatever the connection we have done, that is successful. The IP addresses which I am given to this particular router, right, that is a successful, right? And if you see here also it will be successful. Why? Because we are put it gateway as this particular router's IP address, right? So this 192.168.1.1 we have put it in this particular PC's gateway and also in this PC's gateway, right? So that's why it is these links also in a green color, right? So it will be also a valid connection, right? Then again we need to configure the same router, but with this particular serial communication, right? Serial communication with clock, right? So that's and I wanted to give here the IP address that is 200.10.0.1, right? So accordingly I need to configure this particular port, right? So if you see here, the port number is SE2/0, right? So SE2/0 in the same router I need to configure. So I am going with the same int S2/0, that is nothing but the interface name of this particular router's second link, right? Then I am giving here again the IP address I am assigning 200.10.0.1, again the net mask for the same IP address, right? And I am using here the serial communication with clock, right? So that's why the clock rate I need to mention here, right? So clock rate I am mentioning here the 64,000, right? And again I am putting here the no shut. So therefore this particular interface also can be enabled, right? So no shutdown, so it will be my interface will be enabled, right? So this is nothing but the R0, right? So similarly you need to configure the another router as well, right? So that is nothing but your the router second one. Okay, so if you see wait a minute. Okay, for this particular default serial communication between router, right, we need to assign a default route with the net mode default to both router R0 and R1, right? Because see in this case, in this particular, if you see in the topology also, right, so there will be no any gateway or can be defined in this particular two routers, right? So that's why I am providing here the default gateway as a 0.0.0.0, and it will be also the same mask 0.0.0.0. so it will be a default routing in between these particular two routers I am going to provide, right? And for that again I need to configure in this particular router for the default route, right? And for that there is an command IP space root space 0.0.0.0 space, again the net mask of this particular IP address is again 0.0.0.0 and space is the interface name, right? So interface is which one? Serial communication of second port, right? So S2/0, right? And the same thing again we need to add it for our R1 also, that is now the second router also, right? And then only the traffic is getting transferred from R0 to R1, right? Okay, then we will configure the second router, right? Now this router we need to configure the second router, right? So again this port I have configured, right? The same way I need to configure this port, right? But the different IP address, that makes 200.10.0.2, right? And for the fast Ethernet part I need to put 10.0.0.1, right? So that this particular router also I have configured successfully. Okay, so how to do that? So same thing, just you need to go to the second router, just double click on the second router, go to CLI part, then use the command config space T to configuration terminal of that particular router. Then you need to check the interface S2/0, that is your second interface, it serial interface, right? Then you need to give IP address, that IP address space the IP address of that particular port, then the net mask for that particular IP address, right? Then you again you need to check for the no shut, that is means the that particular interface can be enabled, right? And now the for second one, int fast Ethernet 0/0, then IP address, then again the IP address of that particular part, and then the net mask also, right? And again no space shut, right? So it will be enabled again, right? Then assign then we need to assign the IP address to our server, right? And server and as our gateway, right? So how to do that? So just go to that particular server part. Okay, just double click on this particular server. Okay, double click on this server and just give the server's IP, right? So go to the in a static and give the server's IP as a 10.0.0.254, give the net mask, and what is the default gateway then? the default gateway is nothing but the router's IP address of that particular port, right? So it is nothing but 10.0.0.1. why? Because if you see in this particular topology, right, so the connection is from this particular interface, right? So this particular interface is nothing but the gateway for this particular server, right? So here also I am using routing as a router as a gateway for this particular server. So that's why for here in this server's configuration I need to put 10.0.0.1 as my router's IP address, right? So that I am doing here, right? If you see, so 10.0.0.1, right? Now we need to configure our server as a web server by enabling HTTP service, right? So like what we have done in our DHCP server, right? So we have enabled that particular DHCP server because we need to configure our DHCP server, right? But in this case we need to configure our web server, therefore we need to configure this HTTP, right? So just go into HTTP service and just click on this particular on button, so in order to enable the web server, right? Now we need to check all the connections, right, whether the and identify why NAT is required, and we click on the PC1 to go to command. So for example, if we after this we need to ping all these things, right? So from I'm going to ping from the servers, right, to our each and every interface, right? So whether it will be pinged or not, right? So all are getting I'm getting all the ping, right? So all the communication is established in a well manner, right? But if you see, when we request for a web page, right, we can't directly use the private IP of that web page, right? Because if we can't if you see if in order to access any kind of the website in our Google also, right, you can't get directly the private IP of that particular website, so you will get directly the public IP, right, instead of the private IP of that, right? So for that we need to do the netting part, right? So we need to configure our routers at NAT enable, right, so that private IP of that particular web page can be hidden, and instead of the private IP you can show the public IP to rest of the world, right? And in order to do that we need to configure our router to the global address, which will be public address, which will be accessible from the globally, right? And the local address should be hidden, right? So that we need to do, and for that we have a different command, right? So that is nothing but our IP NAT command, right? So that you need to configure for your second router, right? Why? Because the second router you are connected with your web server, right? So for that you need to configure IP space NAT space inside space source space static netting you are going to do, right? And what is the IP address of that server? That is 10.0.0.254. that is nothing but your private IP of your server, right? That you need to hide, right? And you need to provide the global IP address, right? So that you need to give the IP address of your router, so that is nothing but 200.10.0.2, right? So it is nothing but your interface S2/0, that is serial communication, right? And what you need to again provide IP space NAT space outside, you need to again provide the outside network, right? So this interface S2/0 is nothing but your it will be accessible to your outside world, right? And this interface FA0/0 IP NAT space inside, that will be available for your inside network, right? So after these settings, right, if you go and you can also check with the show spacer, and if you done, and if you are going you can also check inside and outside which are the settings you are done, right? Now you can check with the netting part, right? So whether if for that you can go just with the click on the PC, you can go to the virtual browser, right? And go to the desktop, go to the virtual browser and just fire a command, the public IP of that particular web server, right? Then you will easily access this particular website, right? And if you go with that you can't access that public on that particular public IP, right? So in this way you can translate from private IP to your public IP of your network, right? So in this way we can do the netting part, right? So we will demonstrate it from the Cisco packet on the Cisco packet tracer, right? So let it go with Cisco packet tracer. Okay, Okay, students. So whatever I have told you in our lab manual, right? So about the NATIC configuration, right? So what you need to do is you need to just if you see in this particular topology, right? So just go with the end devices, just drag and drop the two PCs over here, right? Just click on each of the PC, right? And if you go in that particular IP configuration part, right, so you need to give here the IP address. So whatever I have mentioned here, 192.168.1.100, right? And the default gateway I am putting here the router's IP address, that is 192.168.1.1. That is the routing IP address of this particular FA far Ethernet 0/0 port if I am considering, right? So in that way you need to set as a static part, right? So in that way also you need to configure this particular second PC, right? In that also you need to go to desktop and IP configuration, and you need to provide our next IP address, that is 192.168.1.101, and the default gateway as a router's IP address, right? So this also you need to do, and after that you need to configure this particular router, right? So if you click on the router, right, so there are two ways. So from CLI also you can do, from GUI also you can do, right? So in lab manual I have shown you via CLI, right? So here I will demonstrate you via the GUI part, right? So in config tab of this particular router 2, if you go to this particular fast Ethernet 0/0 port, right? So if you go with that, right, so in 0/0 I am giving here the IP address 192.168.1.1, right? And the class C is there, that's why the class C netmarks will be I am going to use, right? The port status is also my on, right? And if you consider this SE2/0, that is nothing but the serial communication with the clock, right? So for that, if you find here serial 2/0, right? So for that you need to configure this particular IP address, that is 200.10.0.1, and respect to netmask for that particular IP address, and also the clock rate you need to mention here. So I am mentioning here 64,000 on my through CLI also, right? So here also through GUI you can assign that, and port status also must be on, right? So these two port of this particular router you need to configure, right? So I am in lab manual I have mentioned through CLI, right? So here I have already my topology is I have done created, right? So here I am going to show you via GUI itself, right? So how to do that. Okay, the same thing you need to do for this particular router 3 as well, right? So just double click on the router 3. Okay, then this is nothing but the CLI for this particular router, right? So just go to the config tab. Okay, now here if you see here also I am going to use the two interface, right? The first one is the serial communication, and here is again the fast Ethernet, right? So if you go into fast Ethernet 0/0, if you see here, so here I am going to configure this particular IP address 10.0.0.1. so going to fast Ethernet port, if you will directly see here 10.0.0.1, the ultimately the subnet mask for that particular IP, and the port is also on, right? And for the SE2/0, that is serial communications 2/0, I am putting here 200.10.0.2, and again the net mask for that particular IP, right? Again my status of the port is on, right? And after that, by configuring up till now, then I need to configure this particular server. So just click on this particular server part, right, and go to your desktop option, go to IP, and here I am giving here for IP is 10.0.0.254, right? So by using static I am giving IP, and for this particular router's IP I need to put it this particular 10.0.0.1, because via this router the traffic goes to this particular server, right? So I need to use this particular router as my gateway, and for that I need to put it here my router's IP as a gateway, right? So after that if you go to service, right, so this particular server is nothing but my web server, right? Because the website I am going to host on this particular server, and that particular website I need to access it from any kind of the system which are available in this particular network if I am talking about, right? So in HTTP you need to just press it on to all the HTTP and HTTPS, right? and just you need to close this particular window. Okay, so this is nothing but the configurations for each and every devices, if you see. Right now, what you need to do is, as I have already told you, I have explained in that lab manual part also, right? That means you need to provide, there is no route for this particular router to router communication, right? So that's why I am going to provide here the static routing for this particular default route for this particular router to router configuration, right? And again, I need to configure this router 2 for my netting part, right? So this FS0/0 must be your inside network connection, right? And SE2/0 must be your outside network connection, right? Because this is nothing but one inside network, and this is nothing but the outside network for this particular inside network, right? So accordingly, I need to change, I need to put it our my NAT command for this particular router 2, right? And if all are set, then what you need to do is you need to access this particular website, right, through this particular number of end devices, right? So for example, I am going to access this from this PC, right? So I just go double click on it, and just I need to go to the web browser of that particular PC, right? And from this, if I need to access this particular website, but here I am doing netting, right? So that's why this particular private IP I'm going to hide, right? I'm not showing this particular private IP, right? And I'm going to provide my router's IP, that is nothing but 200.10.0.2, right? So that is nothing but public IP for my private network or private server, right? So that's why I'm going to use this particular 200.10.0.2, right? And just press go, right? So the Cisco packet tracer is now I am going to access, right? Because I'm done here the static netting, right? And because of that, this private IP of this particular server I'm able to hide that, right? And I'm going to only demonstrate to outside the world to my public IP address, which is nothing but this router's IP, right? So that whenever I'm accessing this particular router's IP, right, the website which will be hosted on this particular server, which will be I'm able to see that particular website through this particular IP addresses, right? So this is nothing but the concepts of netting, how the private IP would be hide, and how to demonstrate the public IP to the rest of the world, right? So this is nothing but the configuration and simulation of this particular netting, that is network address translation can be done. Okay, so I hope you understood this. Okay, wait a minute. Okay, so in this these steps you should be kept in mind that for the both router, right, that means router 0 and router 1, right? So both router for serial communication, you need to configure this particular IP space root space static IP, that is a default root, right? That is 0.0.0.2, and net mask for this particular default IP, that is again 0.0.0.2, and the interface name, right? So that is interface h2/0, and this is nothing but for the both R0 as well as for R1, right? And next one is what you need to do, you need to make sure that you are the netting part, right? So there is a command IP space net inside space source space static, then the server's IP address, which is nothing but the private IP space the public IP that you wanted to show to rest of the world, right? So that is nothing but the public IP of your router you need to showcase, right? So so interface h2/0 is nothing but your outside network, outside netting, and for interface fs0/0 is nothing but your inside netting, right? So this thing you need to do on the second router, right? So these things will be important with respect to this particular experiment is concerned, right? So I hope you will clear with all these things, and how to configure and how to simulate all the netting part or netting server on the Cisco packet tracer. Okay, so that's it for today. Okay, thank you for joining. Okay, so you have now you have understood that how this particular NAT can be configured and NAT can be used, and what is exactly the concept of this particular private to public address translation, right? So if you see in this particular diagram also, right, the first part, that is one private address to one public address you are going to translate, right? So in this particular when the servers on the internal network with you have any private IP addresses, right, and that must be visible from the public network, right, then this particular translation from servers private IP to the public IP can be defined there, right? And if you use this particular many to one, right, that means many private addresses and you need to map it to you over only one public addresses, right, then you can use the end system whatever you wanted to use, right, that will be require the access to the your public network, right, but do not have to be visible to the outside world, right? So in that case also you can use this particular many to one, that is many private IP addresses you need to map it to only the one public IP addresses, right? And the third technique is nothing but the combination, right? That means it is nothing but the you need to combine it to deploy your network, right? So this is the concepts of your NAT, or you can call it as a PAT, that is port address translation or network address translation, right? So I hope you will understand this particular concept, right? So so after this we will see this particular how this particular enterprise can be used this particular private and public IP addresses in their enterprise network, right? So if you see with respect to our SONA architecture, or with respect to our enterprise network design concept, right, so whatever we have studied in enterprise network, right, so if you see in this particular building access, building distribution, or build campus core layer, you can use this particular private IP addresses over here, right? For your server farm also you can use this particular private address over here, right? But with respect to your enterprise edge, right, if you see in this particular internet connectivity also, that is nothing but your ISPs, right? So over here you need to use your public IP addresses, right? And for example, if you see here the remote access or VPN, right, so in that case also you can be use any kind of the IP address over here, public or private, so depending upon the organization or how you are going to connect with this particular ISPs, right? So depending upon that, internally or externally, you can use this kind of the IP addresses over here, right? So in this particular teleworker also you can use this particular private IP addresses, right? And here also you can use the concepts from netting over here. For the data center also you can use any kind of the IP addresses, public or private. And for the enterprise branch also you are going to use the private IP addresses, right? So here also whenever you are going I'm listing out the private IP, right? So for example, branch you are using private, data center you can be used, for teleworker you are use, see server farm you are use this particular, enterprise campus you are again use this particular private IP addresses, right? So all these kind of the IP addresses you need to first of all translate it into your public IP addresses, right? Then for outside the world, these particular logical IP addresses of this particular devices will be not be shown, right? So only public IP address that can be showcased to all other part of the world, right? So this is the main concepts for this particular netting and PAT part, right? So so we will stop today here, right? So we will continue with this particular determining the network topology from our next session, right? So we will stop it here. Okay, so thank you for joining.